Okay, let's go over number 7 on the Unit 6 quest, or sorry, number 11 on the Unit 6 quest. So we are told that the first, fifth, and 13th terms of an arithmetic sequence are equal to the first, second, and third terms of a geometric sequence. We are also told that the common ratio of the geometric sequence is 2. And we are told that in the arithmetic sequence, the 21st term is equal to 72. Now we are asked to find the sum of the first 20 terms of the geometric sequence. And in order to do that, we need A and we need R. We are given R, we're told that R is equal to 2, so we need to find A. Let's remember that A is the same as T1, the first term. So I've done a little table or a chart showing the relationship that we are given between the terms in the arithmetic sequence and the geometric sequence. So the T1s are equal. That means they both have the first same term. And our ratio is equal to 2 for the geometric term. I've put that right up there so that we have that to use in just a moment. So T5 is equal to T2 and T13 is equal to T3. Now, when we have a common ratio of 2 for a geometric sequence, what this means is that each successive term is twice as much as the previous term. So basically, this tells us that T2 is equal to 2 times T1, and T3 is equal to 2 times T2, and so on. Now, we can actually take this information a little further, and we are going to consolidate these two equations so that we have T3 in terms of T1. And this is all to help us find T1. That's what we need to find. So what we're going to do is we are going to take 2 times T1, because that's equivalent to T2, and we're going to put it into that equation T3 is equal to 2 times T2. So that gives us T3 is equal to 2 times T1, and therefore T3 is equal to 4 times T1. Okay, so we're going to keep that in mind. And then we're going to also think about, well, what does that mean for the information in our arithmetic sequence? Because we know that T13 is equal to T3. So this also tells us that T13 is equal to 4 times T1. And yes, it looks like we're mixing up our sequences here, but remember, T1 is the same for both sequences. So we're going to use that information in a moment. Now, let's go back to some information about our arithmetic sequence, where the 21st term is equal to 72. So T21 is equal to 72. Now, we are going to write down our general term for an arithmetic sequence, and we're going to put in our information that is above. So T at n is equal to 72. We don't know what A is, N is 21, and we don't know what D is. So let's simplify this a bit, but we are going to put in T1 instead of A. So we have 72 is equal to T1 plus 20D. And now I'm going to rearrange it and write T1 by itself on the left-hand side. Okay, so we're going to use that in just a moment. We are going to go back to our piece of information about T13 being equal to 4 times T1. So we are going to, again, take our general term for arithmetic sequence, and we're going to put in what we know. So we're doing this for when n is 13. We're going to write T1 instead of A. They are the same thing, they're equal to each other. And instead of n, we're going to write 13, and then we're going to write D. So we have a lot of different variables going on. Now we are going to put in 4 times T1 instead of T13. And we can do that because they are equal. Now we are going to solve and get T1 by itself. So we end up with 3 times T1 is equal to 12D, and T1 is equal to 4 times D. So now we have two equations, we'll call them equation 1 and equation 2, with two variables. So we can now solve for D and solve for T1, and that's it. We need to find T1, right? We need to find T1, we need to find A in order to answer the full question. So what we're going to do is we are going to say, let 1 be equal to 2, right? Because the T1s can be set equal to each other. So that gives us 72 minus 20D is equal to 4D. And we want to get all the D's by themselves. So we end up with negative 24D on the left-hand side and then negative 72 on the right-hand side. D is negative 72 divided by negative 24, and D is equal to 3. So we have our common difference is equal to 3. We're going to use that information to solve for T1. So we're going to put this into equation 2. So T1 is equal to 4 times D, which is 4 times 3, which is 12. So we have T1 is equal to 12. And remember, this is the same as A. So therefore, A is equal to 12. That was our key piece of information that we needed in order to solve for our final sum. So let's do that. So we need to find, actually let's just write down A. So A is equal to 12, R is equal to 2, and we are asked to find the sum of a geometric series. So let's write down that formula as well. And we're asked to find it for the first 10 terms. And you should get a final answer of 12,276.